Hi, here is our first video for section 1.3. Hopefully you've already spent a bunch of time reading the first couple pages on your own and doing those exercises. But I want to do a few of these so I can explain it in some slightly different terminology. But this is the next example on the third page. So we've already talked about this before, but the graph of an equation is a picture of all of its solutions. Just want to do a reminder of that, which means the xy points where the two sides of an equation are equal. So let's take a moment to copy down example 4 to see what the graph tells you about your analysis of the related equation. So you might want to pause here for a moment. And now that you've copied it down and read it, let's start talking about it. I'm actually going to do part B first because I think it's more straightforward than A. So now the graph, the points on the graph here, on the line itself, those are xy points that make ax plus by and c come out to be the same number. Now, we don't know what A and B and C are. There's some specific values, some specific numbers that we don't actually know. And likewise, we don't know what P and Q and G and H are. But that's okay, because we can still answer this question. So let's see. Is this equation true? What that means is the way you got this equation is by plugging in x equals p and y equals q into the original equation. And if you do that here, you can see that, well, the point is not on the graph, which means it's not a point that makes the two sides equal. So this is not true. And similar thing with C here. If you plug in G, whatever that number is, for your specific value of X, and H, whatever that number is, for your specific value of Y, well, that's true if GH is a point on the graph right here. And it looks like it is. So that means the fact that this point is right here, that means that when you plug in that G and when you plug in that H for Y, it makes both sides equals. It makes AX plus B, A times G plus B times H come out to be the same number as C. So that means it is a solution, so this is true. Then A is a little bit weirder. It's not quite as obvious as the other ones what the values of X and Y are. But then if you try to take this equation and write it in this format, like, can you write this as something times A plus something times B to get a result of C? Let's see. Well, the equation that you're given here for A, it looks like there's a 0 times A here. So you could plug in 0 for A, and then 24 times B looks like 24 times B. So those numbers are now your xy point that we're talking about. We're talking about the number, or the point 0, 24, which is right here. And that is a point on the graph, which means that 0, 24 is a solution of the original equation. It means that plugging in 0 and 24 makes both sides equal, so this is true. Okay. So it's weird that you have all of these letters instead of numbers when you don't actually know the specific values, but the same concepts apply as that work with numbers. Here is our first example of solving an equation by graphing. And I wanted to point out that this kind of problem is what we're calling one of the fundamental skills of this course. Problems that are going to come up a lot throughout the course, and problems that you can use to understanding this kind of problem will help you understand a lot of other kinds of problems in the future. These are problems that are sort of like the trunk of the tree that are really useful for understanding more math. You can use this kind of problem to grow some leaves on your tree of knowledge later on. So if you don't understand what I'm doing here, make sure that you ask for help later. So let's see. We want to use this graph to solve an equation. Now, remember, the graph is all of these points here. All of those ones are xy points where when you plug them in, it makes this y the same thing as 285 minus 15x. Now, to solve this equation, we want to know what is the x that makes this 285 minus 15x equal to 150. Now, the point that will tell you that is the point on the graph where the y is 150, which is labeled right here. Because what they're doing here is just replacing that value of, or replacing the variable y here with the number 150, and we want to know what x makes that work. That's going to be that value of x. So it looks like about 9 there. Let's check that. We want to know, is that point a solution of this one? Let's just see. If you plug in the 150 for y, that's going to look like 150 equals 285 minus 15 times 9. And 15 times 9 is 135. So this gives you 150 equals 285 minus 135, which is true. That comes out to 135. So, in other words, 9 is a value of x that when you plug it into this, it makes the right side equal to 150. That's why 150 is a point on this graph, and making y equal to 150 is the same thing as satisfying this equation. So that means the answer to this question, what it's asking us to do, we want to solve this. That means we want to find what x makes it true. So the solution of this equation, which is what we're trying to find, is x equals 9. Okay, here's another problem that's the same idea as that one for you to try to use the graph to solve this equation. Now remember, you could solve the equation by, subtracting 30, dividing by -8, but this using graphs to analyze facts about equations is an important thing to do, so do it this way. And good luck with that. The answers are in the book if you want to check. And I'll see you in the next video where we'll do example 6.